I'm going to be talking about evolution today. I'm going to go over a couple things before I get into the main section of my speech. The first thing I want to cover is what people typically consider evolution to be. The second thing is in cases where evolution went really well. And the third thing I want to talk about is some cases where evolution didn't go as planned, or it did go as planned, but the plan wasn't very successful. Now, first things first, evolution at its basis is scientifically just survival of the fittest. It's whoever has a gene that allows them to survive the best and pass it on to their offspring gets to keep passing it on, and over time and time it starts becoming the norm, and that's what the animal has evolved into, just because that's what has survived. Now, that is a correct interpretation of evolution, but it isn't necessarily the only interpretation of it. When you're looking at evolution, people tend to take into account what we have today as to be the most evolved thing, but that's not true. If you look at humans, humans have evolved from monkeys and apes, but to say that we are more evolved than apes or monkeys is not true. Because if we were put into the same environment that the apes and monkeys are today, we would be less evolved. We would be less suited to that environment, and we would end up probably dying over time or surviving and evolving to be more like monkeys or apes. So every evolutionary step is typically taken to be whatever will get you to survive. Now, in some instances, this really works out. For example, in the Amazon jungles and all these great rainforests, mimicry is really prominent just because of how many animals it is, how diverse it is, and how compact the habitat is. There's a lot of animals there, there's a lot of predators and a lot of prey. Because of that, every single animal has its own individual unique way of dealing and surviving with it. Some prey has evolved to be mimickers. They mimic other things in their environment. Whether that mimicry is of other animals, of other prey, of just their environment. One really good example of this is the mocker swallowtail. They have evolved in a very specific way so that they can prevent being eaten, or at least try their best to. All of these butterflies in this picture are the exact same species of butterfly. These butterflies have evolved to be polymorphic, which that means that whenever they turn into butterflies, to come out of their cocoon, they have a multiple appearances that they can take the appearance of. So we have the yellow ones, we have black and white ones, and then we have a more spotted orange and black, and a more prominent black and orange. Now, all of these are different distinctions within their own appearances, but all of these have a purpose. Every single butterfly that is displayed, every single pattern that it shows, is its own unique form of mimicry. All of these butterflies are, all the butterfly is mimicking different types of butterflies that are poisonous or not pleasant to eat to birds or animals. The yellow one, the black and white one, the orange and black, and the black and orange, they're all different species of butterfly that this one butterfly is copying. It does this that way that the predators never quite catch on if whether this butterfly is really the poisonous one or if it's just mimicking. Because if you keep mimicking the same creature over and over again, over time, predators will start to learn. So that's why this butterfly does this. And it's been really successful in doing so, and because of this, it's evolved to do this, and it stays in the traits. Now, something that doesn't work out as well is evolution's tendency to not waste energy when it doesn't need to. In some cases, this is fine. It doesn't impact the animal, it doesn't affect it negatively or positively, and it's not really in the way of anything, so it doesn't evolve out of the gene pool. A prime example of this would be this nerve, the left recurrent laryngeal. This nerve is only it's connected from the brain to the larynx, and it only has to be a couple inches long. But for some reason, it is evolved in such a way that it actually curls around the aorta of the heart before going back to the larynx. So for humans and most animals, this isn't a big deal. This doesn't affect us like in any way, and it never will. It's just an oddity of evolution. When it comes to other animals, though, that have longer necks, like the giraffe, this same nerve, which only has to be a couple of inches, ends up being several feet. And now, there's no inherent reason for this. There's no reason this needs to be gotten rid of, or this needs to be here in the first place. It's just an oddity of evolution that it's, I guess, kind of like a mistake because it doesn't need to be here. And it's just a waste of space and energy to form. But it's not causing any problems. So evolutionary, it never gets rid of it. It never gets out of the gene pool because it doesn't change anything in terms of survival. Now, in some cases, evolutions of a certain animal go against the intended purpose. For example, there is some research being done that found that some fish have actually started to produce a hormone that increase how quickly they grow and become adults so they can have eggs quicker and breed quicker and create more babies to further produce, their lifespan and extend their species out. And while that sounds like a good idea initially, and you can see why that would be entered into the gene pool just because you grew up quicker, and because you grew up quicker, you're able to mate quicker, which passes it on. But a consequence of that is that this also tends to shorten your lifespan. So researchers have found that these same fish that produce eggs quicker, they grow up quicker, and they produce this hormone, they tend to die a lot faster in the wild. And due to this, they are fearful that this fish is going to, in a way, kill itself through its own evolution. They call this just evolutionary suicide. So while the main goal of the fish was to produce more offspring, and while that works, the side effect is that overall, over time, they will end up dying quicker and quicker and quicker until they can no longer keep producing offspring before they die out and may end up becoming extinct. That is a big problem of evolution and the way it's looked at, that typically things don't really go to plan because there never really is a plan. Things evolve as to be called like the survival of the fittest, which also isn't inherently true. As seen with that fish, it all really goes off what can you do to mate first. And sometimes that can be disastrous. Evolution is confusing and it's weird and it doesn't really make sense. And it probably never will because it's all based off of random variables that nobody really has a control of. And because of that, it'll always be an interesting field to study. If anything else, it just shows how many variations we can have in this world. And that's been evolution.